We're now going to add to the list of functions that we're going to be able to differentiate by looking at the derivatives of the trig functions. We've already been using the fact that the derivative of sine is cosine, and we gave sort of a geometric argument as to why that's true. But I want to formally derive that the derivative of sine is cosine, and a similar method would give us the derivative of cosine, which we'll see. And then we can use both of these to actually derive the derivative of the other 6 trig functions. So let's do sine. So the derivative of sine, I'm going to go back to the definition, and I'm going to use the limit as h goes to 0 definition. And that, just to write it out in its general form, it looks like this: f of x plus h minus f of x over h. And so in our case, we've got the limit as h goes to 0. Our function is sine x, so we've got sine of x plus h minus sine x over h. And there's not much I can do in this form, because letting h go to 0, you're going to get a 0 over 0, and there's no way to factor or clear fractions. There's none of those standard things in here. But there is one thing that I've got that I can do something with, and it's this term right here. I've got sine of a sum of two things, and there is a formula for the sine of a sum of angles from trig. So I'm going to apply that. So the limit as h goes to 0. The sum of angles for sine is sine of the first cosine of the second plus cosine of the first sine of the second. So it's sine, cosine, cosine, sine. That's divided, and then there's this minus sign still here. That's divided by h. And so now I'll just kind of do what I can do. Notice that this term here and this term here have a common factor. So I'm going to pull this one over here without rewriting the whole thing, and I'm going to factor the sine x out of those two terms. So I'm going to have the limit as h goes to 0, factoring a sine x out of those two terms. Okay, so for this first one, I'm still going to have a cosine h. Second one, I factored out the sine, so there's just going to be a minus 1 still there. And then this middle term, I'm moving over here by itself. I can't factor anything out of that one. And that's all still divided by h. And so what I'll do is I'm going to split this up where this term is over h and this term is over h. So I'll do that. This is the limit as h goes to 0. I'm going to have sine x cosine h minus 1. That's all going to be over h. And I'm going to go ahead and pass the limit to this other one. Limit as h goes to 0, and I've got cosine x sine h over h. Hopefully something jumps out at you in both of these terms. There's this there's cosine h minus 1 over h, and this one has the same sort of thing, but it's a sine h over h. Those are two of our limit formulas that we know. So I'm going to just rewrite it, not changing anything other than how it looks. I'm going to put the sine x over here by itself. The cosine h minus 1 over h. That's still the same term here. It's just I broke those factors up. And then this is a plus here. Plus limit as h goes to 0. Take the cosine out in front and leave the sine h over h, because those two limits are ones I can do. So I'm going to look at this now. As h goes to 0, let's see what happens. Well, sine x doesn't have an h in it, so sine x is still going to be sine x, because the h is what's changing. However, this thing was one of our formulas, and if you remember or go back and look, it turns out that that one's 0. Plus, here we go again, cosine x as h goes to 0, that's still cosine x, there's no h in that. But sine h over h as h goes to 0, that's 1. So we end up with cosine x, which says that the derivative of sine is cosine. Now, we didn't actually derive the boxed formulas here either, but it uses some trig, and that's in most textbooks as well. But that gives you a better idea of where this derivative is coming from instead of just looking at that graph. Well, in a similar way, if I were to do the derivative of cosine, I'm not going to work this one all the way out, but give you sort of an idea of what's happening here. If we do the limit as h goes to 0, This time we have cosine x plus h minus cosine x over h. And cosine has a sum of angles formula. It looks like this: cosine minus sine. And so in a similar way, and then this minus cosine is going to be over here. This will be the numerator. But in a similar way, this one and this one have a cosine in it that I can factor out, giving me a cosine h minus 1 again. So that term is going to disappear. It's this term that's going to lead to my derivative. And notice this time I've got a sine x, sine h, and the sine h over h will go to 1, and I'll end up with minus sine x. So it turns out the derivative of cosine is minus sine. So there's our first two derivative formulas of trig functions. Derivative of sine is cosine, and the derivative of cosine is minus sine. And so we'll use both of these then to help us derive formulas for the other trig functions.